There are a lot of theorems that will help us to calculate limits. Some of them we looked at when we looked at sequences and series. Some of them we'll add now, and some are beyond the scope of this course. So let's look at this. On page 574 in your book, you see this limit theorem that tells us if we're taking the limit of a constant, then that limit is equal to the constant for everything. We looked at that with sequences as well. Now, on 575, let's see if I can get up to the top of the page here, we see that if you have the function y equals x, then the limit as you go to that is a. That's an identity theorem. Then we see the limit of sum is the sum of the limits. We looked at that with sequences as well. We see we have the limit of a multiple of a function here is the multiple of the limit of the function. Also looked at that in sequences. Then on the next page, we've got a couple more that we looked at. We looked at the limit of a product with sequences as well, works with functions, and also the limit of a quotient, that works with functions as well. So the limit of the quotient is the quotient of the limits. And then one we didn't have with sequences that we're going to also use is if you have the limit of a function raised to a power, then you can take the limit of the function and raise that limit to the power, and that's the same answer. It'll give you the same thing. So that's called the limit of a power. So look over all of those, pause the video, make sure you've got all those, and we'll try an example. Alright, so hopefully you've looked over those. Let's look at an example so we can see how we can use all of these with functions. As I said, it's the same thing as with sequence, because let's face it, an explicit formula for a sequence is generally a function. So we have the limit of quotients, so we can use that limit of quotients theorem to split them up. And I'm going to go ahead and rewrite this bottom as an exponent instead of the square root. So that's by the limit of quotients theorem. Now we can use the limit of the sum and difference to split up the top. And then we're going to use that limit of powers to change this bottom part so that we have that exponent on the outside of where we're calculating the limit. So this uses the limit of sum and difference, this uses the limit of power. So then on the top we've got the limit of a scalar multiple, so that's 4 times the limit as x goes to 1 of x, minus, and then we've got the limit of a constant here, so we know that's just going to be 3 over, and then here we've got the limit of sum and difference, so we have the limit as x goes to 1 of x squared plus the limit as x goes to 1 of 1, and that's still all to the 1/2. We know that by the theorem, the identity theorem here, the limit as x goes to 1 of x is just 1, so we have 4 times 1, then minus 3 on the top. And then here we've got another power, so we've got the limit as x goes to 1 of x, and that's going to be squared. And here we've got the limit of a constant, plus 1. So we've got 4 minus 3 on the top is 1. On the bottom here we've got the limit as x goes to 1 of x. We know from that identity theorem that that's 1, so we have 1 squared plus 1 to the 1/2. So we have 1 over, and here 1 squared is 1 plus 1 is 2 to the 1/2 power, so we'll write that as the square root of 2. 1 over the square root of 2 is our limit. Now, you may say to yourself, wow, that's a lot of steps to write out. Well, as you practice with limits, you'll get to the point where you don't have to actually write all of them out. You can skip some of them and combine them and recognize that you're splitting them up in your head and you don't have to write out every single step. But while you're first learning and practicing, I suggest you write out every step so that you know what you're doing and you can see how to get those. So make sure you look over those limit theorems. They're, again, almost all of them are the same ones from the sequences from when we first started limits. And so you can use those for functions as well. So do some practice problems. Make sure you've got this down.